I saw a record button here.
Yep, I just started the recording.
Okay, great.
So I've had pretty good luck. I've only recorded a couple of sessions with GoToMeeting, but they both turned out well. You have to do a little post-processing thing with the GoToMeeting, so it'll take a little while after the meeting before it's done and I can share it, but should be no
Okay.
problem.
Yeah, I'll try to record with video cam here as well, just in case.
Always good to have a backup plan.
Yeah.
Let me make sure. Let's see. Not too bad. I think we're pretty well set.
That bag is an EndoLume kit set, right?
Yes, what we're looking at on the screen now is the Endo Illume. This is a small light source here that we'll be changing to. We currently have a product called our L700, which
Okay.
will be in production for a little while longer yet, but we'll be switching to this slightly smaller LED light source in the future.
Okay.
It also, there's a fiber optic light cable here.
Mhm.
So this is a slightly different version than the one that comes in our kit, but it was one that I had in my office when I got ready. So,
Okay.
but basically, you see the EndoLume, all of its fittings, the integrating sphere. We'll talk about all the different parts, pieces, and parts later. And our
Mhm.
reference guide in the back all comes in the kit. Yes.
Okay.
This you see the video? Is it follow okay? Probably a little choppy.
Yeah. No, no, it's okay, fine.
Okay.
Just a little bit of delay.
Yeah,
A
yeah.
little, very like not even a second kind of delay.
Oh, very good.
But it's fine. It's fine.
So my hand right now is on a little camera that does not come with the kit or anything. It's just for me to demonstrate for you.
Okay.
But it's a handy tool to have to kind of record images from the EndoScan to demonstrate the EndoScan function. So
Mhm.
we'll go through everything step by step. Mhm.
Okay. Good. Start from, just imagine that we know nuts here, you know. Start from the basic.
Well, that's absolutely what we'll do. The presentation is designed so that we'll start assuming that you have no knowledge whatsoever of what endoscopes are and what's inside an endoscope. Um,
Okay.
we found that many of our customers in the hospital level really don't have any understanding, whether they're biomeds or central sterile technicians. To them, an endoscope is just a black box that they pick up and look through. So we found it to be very helpful, and we've gotten very good feedback from our customers when we do presentations to include that basic background information on what scopes are, how they work, with all the different types and things. So
Mhm.
for them, they
Yeah, that
oh, go ahead.
that'd be good.
So just for my basic understanding, do you have any knowledge of endoscopes in their operation?
I've seen, but I've not really, not much of knowledge.
Okay, no problem at all.
I've seen rigid, I've seen flexible scope, I've seen light source, the whole system
Hmm.
physically, but how it works really, you know, she saw some videos on some operations and
Yeah. Okay. Well, we'll go through it all in detail. So let me see if maybe I can get a little. My camera's yeah, that's a little better focus maybe. Although I'm losing some of my components here. Let's see.
Is Carl Stoss your customer too?
I'm sorry, what was that?
Is Carl Stoss your customer too?
Carl Storz, they buy many of our endo scans, and we were just actually speaking with them last week. They are apparently very interested in buying an endo bench right now.
All right, great.
So we've worked with them off and on in the past. I don't. Do you have a relationship with Carl Storz?
No, not really. They are one of the big player here as well.
Yeah, of course.
Beside on yes, yeah.
Yeah.
Everywhere. Carl Stoss.
What's that?
I said everywhere. Carl Stoss will have a big market share as well.
Very, very true. I found them to be the type of supplier that likes to kind of keep their customers, pardon the pun, but in the dark. So
Okay.
I think we're starting to make some progress with them. They have some of their end user customers here in the U.S. Hospitals who are using the EndoBench now, and I think the hints that we're getting and their interest in the EndoBench that we've received recently is that they're starting to realize that as Lighthouse educates their customers, it's no longer enough to just tell them that what they have is good enough.
Mm-hmm.
I see email. Bill is doing emails. I'm not sure why he's not in the call yet. Let me see if I can get a hold of him separately. Give me one moment.
Ken, take your time. Maybe. No, no, maybe.
All right, Bill will be joining us just 1 second. Let's see, what else do we have here? So just kind of again, we'll go through some of the basics. I've got here with me a scope that when you look through it, it's a nice classic example of doesn't look too bad to the naked eye, but when you look inside with something even as simple as the Endo Scan, will show how you can find damaged, cracked components inside and things. So
Okay.
we're the latest. Actually, let me make sure I can pull up a copy here. I'm writing a little paper right now. Some of our customers try to use lux meters. So I'm working on a paper right now to explain the details of why that's not a good way to measure these things.
Good morning, gentlemen. Sorry for my tardiness.
Yeah, good morning, Bill. How are you doing?
Good morning, sir. Hope you're doing well.
Yeah, I'm doing perfectly well. You had your coffee, had your breakfast?
Not yet, but that's okay. You're more
All
important.
Right.
So this should be hopefully interesting for you to get a chance to understand in the next two sessions. We'll do the EndoBench on another day, but for the EndoLume and EndoScan, hopefully this provides you with the information you're looking for, and we can always build upon this training session and system for you, going forward.
Okay. That's
And
great.
please feel free to ask questions throughout.
Okay. Great.
Yep, definitely easier from my end if it's a little interactive, but it's always harder to do that, of course, in web meetings and things. So the downside to technology. Okay, we just jump right in, or
Yeah, okay, we can start. Yeah.
okay?
Yeah.
Oh, guess I'll have to do the roll here. Okay, so we'll start with just some background on Lighthouse Imaging. We were founded as a company in 1984 by Dr. Dennis Liner. Dr. Liner is still our Chief Technology Officer. He has some of the early seminal patents in endoscopy. He's basically spent his entire life's career designing and developing endoscope optics and test equipment. We developed our first EndoBench as a manufacturer in 1995. Most people in many scope manufacturers, we were just talking a little bit, Bill, already this morning about Karl Storz. Many scope manufacturers, even to this day, don't have very sophisticated equipment. They use just well-trained technicians to evaluate the quality of their scopes. Lighthouse, back in as early as 1995, saw a need for more objective numerical analysis of image quality for purposes such as QC or final user testing. So we developed the EndoBench early on. We currently have 3 divisions. Test and measurement is what we'll be talking about here today, is one of them. The other 2 kind of legs of the stool for the company are we do endoscope design and development as well as manufacturing. So that's kind of the forte of the company, is we do development for primarily other manufacturers. The only Lighthouse branded equipment you will typically see a few of our couplers, but mostly just the test and measurement equipment. So the Endo Illume, Endo Scan, and EndoBench, and the L700. The other products that we manufacture are private labeled OEM development projects. So, and again, we also do manufacturing in those areas. So,
Okay.
We are an ISO 13485 and a 9001 certified company, as well as an FDA registered medical device manufacturer. And the company was acquired by a local investment firm, Anania and Associates, back in 2010, which has given us a little bit deeper pockets and ability to kind of expand and grow the company over the last few years. So with that, as we were discussing a little bit earlier, we'll start the presentation off with some background of endoscopy, what scopes are, how they're used, and what's inside them a little bit. So the parts of the endoscopy field that Lighthouse equipment, test and measurement equipment is focused on is rigid endoscopes, flexible endoscopes, including both the fiber optic as well as chip-on-tip style. We'll talk a little bit more about what those mean in a little bit, as well as the light sources and the light cables that carry the light from the light source to the endoscope. Kind of the key on this slide to note is that Lighthouse does not do any work with the camera systems, the towers, any of the electronic backside there as far as our test and measurement equipment goes. So our emphasis and our background is optics. So we concentrate on testing the truly optical components of the systems. When we look at the entire field of endoscopy, there really are very, very few and far between standards for testing and performance. There's a couple of ISO standards. There are a couple of very specific FDA application standard and recommendations, but they're really by application. They're not industry-wide standards. There's 2 ISO industry-wide standards. However, these ISO standards are fairly old, fairly simple, and in our opinion, out of date. Dr. Liner and I are both on the ANSI committee reporting into the ISO organization, and we are currently working actively to kind of update and enhance the ISO test standards for endoscopes. Obviously, our hope and goal is that we will merge the ISO standards with the EndoBench test standards. But as of this point in time, there are some differences between the ISO standards, and again, in our opinion, the ISO standards are very simple and obsolete. China has oddly enough come up with a very thorough, in-depth, and even including some performance specification standard, this YY0068.1, a 2008 release standard. However, it really is developed from sort of the optical designer's point of view and not an end user's point of view. It's a very complicated standard. It assumes that you have probably at least a PhD in optics and an optics lab to work with to make the measurements that it suggests. So that was kind of the impetus to work with the ISO committee to kind of find a middle ground between this very complicated optical design standard that Mr. Jia, the Chinese SFDA, has come up with, and these very simple, obsolete standards that are currently existing in ISO standards. So our goal right now, and I think we're making some good progress on it, is to create some ISO standards that, like I say, cover the middle ground, and they're thorough enough to evaluate the performance of an endoscope, but simple enough that they can be performed in a hospital type setting, which is exactly how and why the EndoBench was developed. Again, we won't talk much about the EndoBench today, but that just gives you some background and where we'll be heading and where we're at with our product line. So as I kind of referred to earlier when we were waiting for you, Bill, was Karl Storz is one of the companies that my experience has shown is kind of the type that prefers very little published performance standards. We currently have several of our EndoBenches in a major OEM in Germany, and that company has started to share its data with its customers, I should say, and we're getting that trickle down of data in that direction. And I think we're starting to make some progress now in getting all of the OEMs and the hospital levels and everybody in the industry, the ISOs and repair companies, to start to expect data as opposed to just a pretty picture and a description of how good the scope is. So anyway, that's where we're at and where we're headed.
Okay.
So this next slide, we're going to take a little quick look, get into the details of the function and applications of the endoscopes. So this slide just kind of shows all of the different types of scopes. Typically, as many medical products, are very unique names depending on their application. So even though all of these scopes are still basically the same function, look in one end or have a camera at one end and insert the other end of the patient, they all have very specific names based on their application. So an encephaloscope for brain activities, a laryngoscope is typically used with an intubation tube. I've kind of highlighted here 3 of the most common scopes that you'll run into. So in rigid endoscopy, laparoscopes and arthroscopes. Laparoscopes are for abdominal surgery typically. Arthroscopes are for different joints, so knees, shoulders, things like that. And then, of course, the flexible side, the by far most common scope that everybody's often had an encounter with is a colonoscope. So those are the typical ones. Colonoscopes are most commonly chip on tip, and we'll talk a little bit more about what that means in a minute. So in general, those classes of endoscopes, again, are flexible endoscopes are often what are used in what are called endoscopy suites. They are typically scopes that use natural human orifices for access into the body. They can be, again, either fiber optic or chip on tip. And also, again, the most common type would be the colonoscope. And I'm not sure how much news waves it made in your area, but the duodenoscope issue that Olympus had here in the U.S. and California about a month or so ago, that's another type of flexible scope. It's basically an adaptation of Olympus's colonoscope, where they had some cross-contamination issues with some of these bacteria resistant or antibiotic resistant bacteria and things. On the other side would be rigid endoscopes. These are surgical devices. They typically then would use a man-made access port orifice into the human body, a surgical incision and a trocar would be the typical way to use a rigid endoscope in, say, a laparoscopic procedure, or arthroscopic would just be a small incision and then inserted into the joint. They are most commonly still rod lens stack endoscopes, and we'll look at what that means inside in just a moment. However, there are getting to be a few unique applications of chip-on-tip rigid endoscopes. Our experience has been that those primarily are restricted to some of the 3D applications nowadays, and that's where some of Lighthouse's development work is occurring right now. But there are some niche applications going forward for rigid endoscopes to use chip-on-tip technology. And again, we'll talk about what that means in a second. So once again, the most common rigid endoscopes are laparoscopes and arthroscopes, although there are certainly other types, cystoscopes and others.
Excuse me, Tim, can you speak maybe a bit louder?
Sure. See, I'm about as close as I'm going to get to the computer. I'm not sure if I should maybe try switching to a phone if this isn't working very well. Let's see what we can do to just speak up a bit.
Yeah.
Let's see. So as far as rigid endoscopes, this is actually kind of an older model of the way a rigid endoscope would work, with unique discrete lenses. And are you still there?
Yeah, wait. Okay. Yeah, I'm here now.
Okay. So this is just a fairly basic slide discussing the flexible endoscopes, the fiber optic version of them. They would have an objective lens at the left end of the bottom image here, and then the image is actually relayed to the eyepiece or the ocular lens using fiber optics. And they are either fully flexible or semi-rigid is one of the more common ways to see that type of endoscope now. And we'll flip to the next slide, and we'll look at the more common version of construction of a rigid endoscope. So we'll see in the upper image here, starting at the left end of what's shown here is be typical for an arthroscope. We'll see the distal window, and then we'll have an objective lens assembly, which you could most typically think of as being like a camera lens. So that creates the image. And then there's inside of these rigid endoscopes are typically a series of rod lenses. This is a long, skinny piece of glass that transfers the image along the shaft of the endoscope. So in between these rod lenses would be hollow tube spacers. And then at the right end, or the proximal end, would again be this ocular lens and the eyepiece window to present the image to the user or to a camera clipped to the endoscope. At the same time, going in the opposite direction of flow would be the illumination bundle fibers wrapped around, typically speaking, the lens system. So the construction of rigid endoscopes most commonly is kind of a tube inside of a tube inside of a tube. The inner tube being the optics, a middle tube being the illumination fiber bundle, and then the outer tube being the sheath that we interact with. The kind of key thing to note in this system is that it is a very complex and fragile glass system. So from the distal window all the way back to the eyepiece window, the system is just filled with glass components. So if you've seen endoscopes in use, they have a little flex to them, and particularly things like arthroscopes. Orthopedic surgeons will often use them as pry bars when working on a patient's joints. So these devices can be fairly easily damaged through dropping, through handling, and through those different types of activities. So again, the key point to take away from all of this is that a rigid endoscope, while it looks very simple from the outside, is quite a very complex and delicate glass optical system inside.
Yeah, it's a lot of engineering.
Tim, is your mouse? Hey, Tim, sorry.
Yep.
Is your mouse or cursor working? I didn't see it moving on my screen.
No, I wasn't showing with the cursor.
Okay.
Just
All
by
right.
description.
Okay.
So this one, actually, I'll probably mouse around on a little bit because the key point here is that the system of a flexible endoscope, like common Olympus 180 series scope, which could be a colonoscope or duodenoscope, is a very, very complex mechanical system. So there are electronic and mechanical control components. On the left end over here, we see the interface to the processor tower system. Fiber optic illumination fibers go through there into the control body. Typically, there will be controls for both horizontal and vertical articulation of the tip. There may be remote control switches. There may be access ports for working channels, followed on the lower right of this image by the insertion tube. This is the length of the scope that's inserted into the body. Then when we get to the very tip of this scope, we get to the optics. So with these flexible scopes, they're very, very complex mechanical and electronic systems, but relatively simple optical systems. So out of this entire assembly, which may be 2 or 3 meters long, there's only maybe 15 millimeters at the tip of it that are optics. The rest of it is all mechanical and electrical, and some illumination fibers, but as far as imaging optics, there's very little. So this next slide shows an actual system that Lighthouse has developed for a chip-on-tip application, like one of these colonoscopes. So this is the entire optical system. This is about 4 millimeters in diameter and about 10 millimeters long. At the right end, we see the camera chip. At the left end, we see the lens train system. So there are no relay components, no rod lenses, no relay lenses of any sort. This tiny system is pre-focused and is basically the entire optical system. So when it comes to testing the optics of flexible scopes, they typically are kind of more either good or bad. But the purpose of the Lighthouse tools in those cases are to make sure that the quality of the components that goes back into them is equal or better than the OEM. So that's some background on the endoscopes themselves. Again, we also test light sources and light cables. So we'll just do a couple of images here of typical light sources. So on the left, we'll see a typical 300-watt xenon light source. This is a very common basic style of light source that you'd find in a surgical tower. Each brand has their own different specific look to it and things, but the 300-watt xenon is kind of the de facto surgical standard. On the right, we'll see our Lighthouse's L700 LED light source. More and more, I believe Stryker has gone to primarily LED sources, but still many in the industry are the xenons. But definitely the trend is towards the LEDs with a longer life and more stable output. Both of these light sources, you'll see on them have multiple interfaces. The Smith & Nephew source shown on the left here, the Dionix, has a little sliding bar here with 4 different interface ports on it. And the Lighthouse L700 has probably a little more common turret type system where each of the different brands of cables can be hooked into it just by rotating this turret to different settings. That's kind of a key point that we'll get to with the EndoLume, is that each of these different settings has very, very different optical characteristics if you don't interface with them the same way that the cables do. When you use the correct cable or a tool such as the EndoLume, the interface is very consistent. If you try to measure these outputs with something more like a lux meter, they are very, very different optical characteristics from one to the other. So then the final type of product that we test are light cables. No need to go into too much detail. We just have a picture here of a typical light cable and the fiber optics that are inside. Typically these cables are made of bundles of thousands and thousands of glass fibers that are like the size of a human hair inside, just a couple, 50 microns, 100 microns, those kind of sizes. So they can have various amounts of breakage in those fine fibers. So moving on to the products that Lighthouse manufactures to test these different components. Do you have any questions on the endoscopes and functions at all first?
So far, no.
Okay.
Yeah, no, so far, no.
So this slide kind of goes from simplest to most complex as far as our products go. At the simplest end is the Endo Scan. This is a tool that you can use to examine the internal components of primarily rigid endoscopes. So it will not evaluate the image quality, but it will find kind of hard failures, definite problem areas inside the optics of rigid endoscopes. Next up in our ladder of products would be the EndoLume. The EndoLume is going to give you an objective numerical measurement of illumination quality of a light source, a light cable, or an endoscope. So instead of kind of having to guess or use some kind of simple and difficult to use other types of tools to decide whether the problem in surgical theater is with the light source or the light cable or the endoscope, the EndoLume will actually do a very quick and simple and numeric analysis of these components. So that's one of the most common errors or problems in surgery is a dim image. And when that happens, often a biomed will simply replace the simplest components. So swap a cable quickly, maybe put a new bulb in the light source. But at that point, they're just reacting and trying to solve the problem however they can instead of using tools to actually isolate the problem and determine exactly what it is. So the EndoLume allows you to test these components very thoroughly and know for certain whether they're good or bad or even just on the edge. So we next up have the EndoLume measurement kit. This packages the EndoLume with a light source and a light cable. So for the biomed or central sterile technician, they typically don't have access to these other components. So if you wanted to test a light cable, you would need a light source to do that. or if you wanted to test an endoscope, you'd need a light source and a cable to hook up to it to do that. So surgical light sources and medically rated cables are fairly expensive and not often just laying around in a biomed or central sterile department. So the EndoLume measurement kit packages these together for their use. Next up, we've had some success selling what we're calling our triage package. And this takes the EndoLume measurement kit and adds the EndoScan in. Therefore, particularly in a central sterile type environment, they can now do a quick analysis of all of the components, the illumination side of endoscopes, as well as a quick visual inspection of the inside of rigid endoscopes, all with a simple, small, basically, kit of parts. Then at the high end, we have our EndoBench product. We have the EndoBench XT and the XTB. Basically, I think you would have gotten the paper we just put together on that showing the differences between the XT, which is the portable version, and the XTB, which is the bench model version. So we'll save the real detail work with those for the next session that we do. But those products basically will provide you an objective analysis, objective and numerical report on the image quality of endoscopes. So our products currently are sold in everything from the biomeds and the central sterile people in the hospitals up through surgical centers, third-party repair centers, ISOs or independent service organizations, and endoscope original equipment manufacturers. So again, our kind of goal and hope, and where we've made very good progress, is getting everybody on the same page as far as exchanging data and kind of determining what means a good scope versus a bad scope. Prior to the success the EndoBench has had in the market, again, the only real kind of gold standard of testing has been, a trained technician's opinion on scope quality. So we're trying to get away from that and make sure that everybody's talking about the same things and using objective numerical data to compare them. So, any questions at all on any of that topic?
No.
Okay. In that case, we'll get into working with the actual products. So again, we'll start with the simplest, and we'll talk a little bit about the EndoScan. So the EndoScan allows you to quickly and efficiently screen rigid endoscopes for internal damage, such as cracked lenses, foggy lenses, dirty lenses, which typically comes from kind of two sources. Dirt on lenses can come from either kind of a poor environment during assembly in a third-party repair, for instance, or it can also come from degradation inside the components if they're starting to break down and create some debris inside during operation. And then also fluid infiltration can be detected. So this next slide shows some of the sample images of things you can see looking inside of an endoscope. So remember again that the EndoScan, when we look at it in a moment, is not evaluating the image quality. It's not looking at all at what the surgeon sees. It's actually looking inside at those different components of the rigid endoscope that we talked about a few minutes ago. So when we look with the EndoScan inside of an endoscope, we're looking at the ocular lens, we're looking at those rod lenses, and we're looking at the objective lens as we move the scope under test through the EndoScan range of motion. And again, we'll see that in a moment, make a little more sense, I think. But here we see some sample images of moisture intrusion at the top and dust at the bottom. I should probably reorder these because I usually talk about them side by side. But you'll notice that the dust or debris inside would typically be fully opaque particles, whereas moisture would have that kind of clear in the center because it's actually a droplet forming. and then opaque on the edges. So that's kind of how you can tell the difference between whether you're seeing moisture or debris. And then another very common fault to detect inside of an endoscope would be rod lens breakage. And you'll see various degrees of this kind of fractal pattern, this fracture pattern inside the broken rod lenses. So with that, we'll switch over to the live view camera, and we'll take a look here. This is the Endo Scan. Hopefully that's visible enough for you.
Yeah, visible. Yeah.
Okay, and
Yep.
here I have a typical 4mm, 30-degree inclined direction of view arthroscope, it would be called. So the tip is actually at an angle. Again, this would be an arthroscope for joint surgeries or joint inspection of some sort. So we're going to start off clipping the camera to this. So I just have a C-mount similar to a surgical camera with a camera coupler lens system attached to it. So this is how the endoscope would typically be used during a procedure. And we're going to switch over to another camera now. And I'm going to take a look at the image through this scope. Add a little bit of light to it here so we can see what's going on. And what I'm going to actually do is just look at a business card. So we'll see. Let me get this spun around here. And we'll focus the camera a bit. And we'll show you the quality of this image through the scope. So this is to a layman's looking at the scope. I can get it to hold steady here. Let me see if I can find something to kind of prop it up with.
Is it possible to slide that screen over so we can actually we can see what you're doing? Oops.
Yeah, that would be a good idea.
So you want to see both of these at once?
Is it possible?
Both at once, yeah.
Okay, let me see what I can do here.
There you go.
So what we've got here is the camera with the scope hooked up to it. I've got a little portable light source just easily hooked to it for right now. And I'm aimed with the scope at a business card. So we can see, looking through this scope, that the text certainly is readable on this business card. So I've shown this scope to a biomed technician or a central sterile technician in the past. They've done this quick and simple test, look through the scope. Need to get something a little better set up here to show this. Look through the scope, be able to read the text and say, yeah, that looks like a good scope to me. I would pass that and put it back into the rotation. In reality, if we look probably very quickly, we can just switch over to a truly good quality scope. And you'll see that even without, add a little bit of light to this. So that is the kind of image you should get through a good quality scope. So this scope is definitely not as high quality as that scope. However, again, that kind of layman's quick look inside that scope, they can read the text. It passes their simple test. You know, they can see colors, they can read the text there. It's a good scope. They put it back into the rotation. So what we'll do next is we'll take this scope and we'll clip it to the EndoScan. So the EndoScan here has a small silver knob that adjusts the position and a small brass knob that attaches the endoscope to the eyepiece mechanism. So you simply insert the eyepiece into the EndoScan and tighten the brass knob, and then you can loosen the stainless knob and adjust the position of the endoscope in the EndoScan.
Okay.
So that's how the EndoScan works. What you would do then is, while you're doing that, you would either look through the EndoScan or, as I've done here, attach the camera to the EndoScan. And now we're looking through a lens in the EndoScan inside the endoscope at the components inside. So if we look at the small kind of yellow image, what I've done is I have a light source hooked up to it, and this rubber tip I put on the end of the scope gives us a nice even reflection back into the scope. You could do the same thing if just manually looking through this by aiming the scope at, say, a shaded window or a fluorescent overhead light with a diffuser on it. But I just put this clip on it so that I can hold it here in front of you.
Hey, Tim, can you, after you're done, just show normally how it would be used by the human, by the eye, looking through it by the eye?
Sure. I mean, it's just an eyepiece here, so
yeah,
hold it up to your eye and look through it. So
that's how it would normally be done. We're just using the camera so you can see the image on the inside.
Ideally, if you have a camera available, that's probably a better way to do it. You get a magnified image, but the typical way to do a quick check would be just to look at it through the eye. So again, you just look into this eyepiece, the same as you would in the eyepiece of the scope itself. So when we attach it to the EndoScan here, we'll see, if we now watch the yellow tinted image, as I slide the EndoScan in and out, we see different features come into focus. So I'm going to zoom a little bit here, and we'll see that somewhere in this endoscope, we can see a little bit of debris on one of the surfaces. So there's a few small particles, but it's not terrible. And this is debris, not moisture intrusion. We can see that they're all small opaque components. And as I mentioned, this is not would in any way be considered severe debris. So this is just a little bit of minor debris. However, if we keep looking deeper and deeper into this scope, blow this up a little bit, we're going to see here that this is a cracked rod lens. So we can actually see two black lines in it, they're the actual cracks, and then we can see to the left of the yellow image and a little bit to the lower left of that image some of that kind of fractal fracture pattern occurring. So this scope actually has a broken rod lens inside of it. So by looking inside of it with the EndoScan, we can see that damage.
So as you're sliding the scope through the EndoScan, you're seeing it from the close end all the way through the series of rod lenses to the other side.
Okay.
So again, starting, typically the way that you would kind of suggest that it be used would be to start all the way out. What's happening there is that there's the lens inside the EndoScan near the eyepiece that's focusing on the eyepiece of the endoscope. As we move it closer, we're looking at components inside. So we go from the ocular or eyepiece lens, and then we start to look inside the rod lenses. So as soon as we go inside, now we see that somewhere in that rod lens chain is this broken lens. As I get closer and closer, we see that somewhere towards the objective end of the endoscope is that debris field kind of pattern. And then as we go farther in close, we see that there's no damage up there. So for instance, if I were to put my finger on the very tip of the scope, you can see some details of my finger at that stage because we're looking at the exit end of the scope. So that's the function of the EndoScan. It actually looks through the different components inside the endoscope, looking for damage, physical damage to those components. Any questions? Anything else you want me to cover, Bill? Or
no, I think that's so. It gives the user in central sterile just a quick tool to visually see if that scope has any, as Tim pointed out, any defects or cracks or disruptions within either the objective side, the ocular, or the eyepiece, or in between in the rod lens side. And in the marketplace, you'll find there's a Fluke has a product similar called their Dale, D-A-L-E 301, but it's almost, if not more than twice our price. So it's very expensive. In fact, most of the Fluke distributors that we have sell our product and not the Dale 301 because of the price issue. And ours is a little more rugged. Ours is made of metal, not plastic.
Okay.
Better quality lens too. They use a plastic lens in there, so we use a glass lens.
But you see, if you find the lenses, there's something wrong with that unit. Normally they replace the whole rigid scope, right? Or can it be repaired part by part? They cannot, right?
Definitely repair companies would open this scope up and find the one broken rod lens and replace it.
Oh, okay, they can do that, yeah. So
Yep,
small.
absolutely. Yep, no, that's their specialty. Now, what the EndoScan or none of our products really do is tell you exactly which component inside is bad. So, if you were to sell this to a scope repair company, it won't tell them which rod lens is bad, because that rod lens, when we think back to that image, there's a whole series of rod lenses and spacers. Each one of those forms and reforms the image. So they basically all look the same to the EndoScan looking inside. So you really can't tell which one of them is broken, just that one of them is broken.
Okay.
But what the EndoScan...
So normally what they do is that they replace the whole thing, right? The inner components.
Well, from the end user's perspective, you can tell that the problem is in the objective lens, the rod lens, or the ocular lens by where you saw the problem in the scale distance. You can then send it out to the scope repair company. They would repair it, and you should get a report when it comes back that says they either replaced a rod lens, or they did an adjustment in the objective lens, or they fixed something in the ocular lens. So that's one of the features that we found that our hospital users, they really enjoy about using the EndoScan, is it's kind of like taking your car to a mechanic and having no idea what the problem is. They give it back to you and tell you they did something to it, but you have no way to know if that sounds right or not. By using the EndoScan, you have an idea, should the problem have been in the ocular portion of the scope, the rod lens portion of the scope, or the objective lens portion of the scope. So you can now have at least somewhat of an intelligent conversation with your scope repair company and tell them you believe it's, in this instance, it has a broken rod lens. So when the report comes back from your repair company, it better say that they replaced the rod lens.
Okay.
So we found that
at the hospital, so at the hospital, the doctor, let's say, would be looking through that particular scope, and he would have trouble getting a good image, and he may not know what's wrong. But back in the central sterile area or the biomed area, whoever is responsible for the maintenance and inventory of the scopes could take the EndoScan. In this case, it's a simple tool, and they could look through that and say, oh, okay, I see the crack. No wonder the doctor was complaining. This scope is damaged, so we need to either send it out to our repair company or replace it, depending on what type of arrangement. In this country, as well as Europe, but mostly this country, there's a large industry here of scope repair companies that go to hospitals and repair OEM products and basically try or do bring them back to OEM at least standards.
Okay.
We'll probably talk about it a little more in detail in the EndoBench session, but it is certainly possible for scope repair companies, third-party scope repair companies,
Okay.
Every bit as good a quality as the OEMs do. However, it's also possible for them to do very, very poor quality repairs. So with the EndoScan and EndoLume, and particularly the EndoBench, evaluating, the quality of your scope repair company is one of the key functions of these products.
Okay. But we don't have any scope repair companies here in Malaysia.
Really?
Yeah, the third party one.
Huh. So all of your repairs.
So it's all strictly.
They send back to the US or to the manufacturers.
Huh. Interesting.
Very interesting.
At
So
least with our tools, then they can, here in the U.S., and I guess it's typical there, of course, it depends on the contract that they have with the OEM. But here, each time a hospital, once they buy the scopes and it's in their inventory, every time they send one out, if they think it needs to be repaired, they get a charge. And it can be anywhere here, it can be anywhere from $500 to $1,000 per scope. So if they think something is wrong, they send it out, they get charged. With our equipment, what you'll learn, especially when we get through the EndoBench, is that if used properly, they have tools that will allow them to determine if that scope is indeed has a problem and should go out for repair, or does not have a problem and it doesn't need to go out for repair. And we'll explain more about that as we get into the training.
Okay. Great.
So
with the EndoScan, what do you supply with the EndoScan? Only that piece of metal there and the yellow thing there, or?
yeah, not even the yellow tip. All we provide for the EndoScan is, yes, this aluminum and steel and glass viewing mechanism.
Okay.
Because mostly when it's used, as Tim showed you, it's once they put the scope in there and hold it up to their eye, it's like viewing almost a telescope type thing. They'll hold it up to a light source in the room, maybe, or out a window, and then you can get light. It's very easy to get light in through the tip of the scope, and by moving it up and down on the track, they can do what Tim showed you. They can run from the objective side or the camera side, basically, to the eyepiece, and basically you just hold it up that way.
Yeah. You see where is the problem? Okay.
Any other questions on the EndoScan then?
Do you have any question? Huh? Okay, there is a scale there, right, on the silver
Yes.
screw. Yeah. What is that for?
It's primarily so that you can show somebody else the issue, or if you are interacting with another company, like a repair company who also has the EndoScan, you can share information with them. Again, it's not that you can tell by this scale exactly where inside the problem is, but the problem will show up at the same point. So here again, I'll move the EndoScan to where we can see the
Hey, Tim, hold that closer to the camera so they get a better idea of the scale, if you can.
Yeah, it doesn't show up very well either way, but
Okay.
centimeters. And you'll see in the yellow image there that I've set it where you can see the fracture. So I could lock it down there, and now we see on the scale, there's a small tick mark here that shows we're at about 4.5 centimeters.
Okay.
So
Okay.
everybody's eye focuses a little differently, so this is going to be an approximate measure. But, a scope such as this one has a very obvious flaw in it. So you could send it out for repair or to show to somebody else and just go, it's about 4.25 centimeters. You'll see this failure, this fracture pattern. If you had something a little more subtle, some debris, or probably most importantly would be some moisture leakage that you could see, Obviously, if there's moisture leakage or leakage of any sort, there's issues for potential contamination, cross-contamination. So that's something you might want to point out that would be a little more subtle. If you just saw a few droplets, maybe something that's a little harder to point out and see. So you could adjust the EndoScan to where you found the moisture droplets, take note of where that location was, and then show it to somebody else later on, or another company using the same EndoScan, send it out for repair and tell them where you saw the problem, so that they, you could all agree that the problem is there and seen.
Okay. Got it.
Very good questions, by the way. Thank you.
Thank you.
So, should we move on to the EndoLume now then, or?
Yes, we can.
Yes.
Okay. So we'll go back to the presentation for a few moments.
Okay.
Again,
So you pass us the copy of the presentation.
absolutely. So when we look at the EndoLume, again, it's an endoscopic system illumination tester. So it tests strictly the illumination side components. Light source, light cable, endoscope. So it will test the transmission efficiency of endoscopes. It will test the light source output, and it will test the light cable transmission efficiency. So with any of these fiber optic components, which would be the endoscopes and the cables, it's really that transmission efficiency that you're most interested in. It's the output divided by the input times 100 to make it a percentage. But you really care what portion of the light coming through into the device is making it through the device. So as we'll see when we do demonstration, it's not at all uncommon to have only a few percent of the light that's made in the light bulb or the LED source actually make it through into the patient. So as far as the function of the EndoLume, it is a NIST traceable calibration. So we use NIST traceable standards in our calibration process. We are measuring total optical light power, which is called lumens. And again, I mentioned that we're finishing up a paper right now to explain the problems and differences with some of your customers may be using a lux meter to measure these things. And a lux meter is not at all the correct tool to use to try to measure.
A couple of months back, Stryker bought a lux meter from us.
Oh, okay.
Yeah, this was like 3-4 months ago. Yeah.
Interesting.
Just, yeah, to test the scopes.
Well, we'll give you some ammunition to use to sell them an EndoLume instead. So
yes, now you can tell them that you found a much, as we finish this one, you'll be able to tell them you now represent a much more effective device. So you'll see when we finish.
Yeah, we actually spoke to them, but we have not presented in detail. They are quite interested and to see the presentation and product. Yeah.
I think they will like it. I think you will like this as we go through this. So the EndoLume includes the adapters for typical endoscopic products. So the sources, cables, and endoscopes. Down at the bottom, we talk about the ACMI, Wolf, Storz, and Olympus being the common ones. We also use what's called an integrating sphere. This provides a much more consistent and even measurement, and it allows the measurement of the output of a scope tip, which doesn't have a fitting. You need to just collect the light from that. These are places where typically lux meters have very much difficulty in making any kind of repeatable measurement. And then the last big area difference between trying to use a lux meter and an EndoLume is we include a patented feature called the light bridge. What this does is that no matter which type of light source you're using, and most importantly, when you have those sources, as I showed earlier in the presentation, that have a turret or a multiple port setting, the output from those different ports, if you try to measure it with a lux meter, can vary by a factor of 5 or 10, depending on which one you're using. So you'll get a totally different answer just by changing the turret setting. Whereas the EndoLume interfaces the same way with the light source that the light cable does. And you should only see a few percent change at most between all the different turret settings using the EndoLume. In addition, what we can do is we provide, this is, let's see, I'll have to bring it up and show you in a little bit. This is one tab of a spreadsheet that we can provide the end user or yourself that helps you interpret the data that you measure through the EndoLume. So again, the main point of all of our test products, our hope anyway, for our EndoLume and EndoBench, is to provide numeric objective test data. So it depends on the application what you consider acceptable output. However, we provide the data to do that repeatably and set these limits. So again, this is kind of starting point data where with a 4 millimeter 30-degree arthroscope like I was just looking at, you should get somewhere around 10 or 12% minimum transmission. With a 5 millimeter light cable like I'll be using, you should see about 35% minimum transmission. And I don't have a xenon light source here for the demonstration, but a typical minimum light output of a 300 watt xenon light source may be 1100 lumens. So if we look at this, if we started with 1100, well, let's make this easy. We'll start with 1000 lumens. If we hook a light cable to it and get 35% transmission, that means just going through the cable, now we're down to 350 lumens of power. If we then go through an arthroscope that has maybe a 10% transmission, we maybe only have 35 lumens then of final power. And we'll show those measurements in a demonstration now in a moment. So starting with over 1000 lumens, you could wind up with as little as 35 lumens of output power. And these are typical normal results. However, it kind of demonstrates that any damage to these components can make significant differences in the usability of the products. So this is just kind of visually reiterating what we talked about before with our EndoLume measurement kit. You get the EndoLume and all of its fittings, a light cable, and a light source. So you can do these measurements without needing any other components from the surgical theater. And then our EndoLume triage package takes that EndoLume measurement kit and adds the EndoScan to it. So again, now you have the ability to do a quick analysis of the illumination side of the endoscope system, as well as the optics of the rigid endoscopes.
So Margit, go back one slide. I'm sorry, Tim.
Sure.
There you go. This package is what we are selling here in the U.S. to the central sterile teams.
Okay.
As we talk further, the EndoLume in itself is an excellent product for the biomed department for what they want to do, test light sources, light cables, those kind of things. Mm-hmm. Depending on the hospital, whoever is responsible for the scopes themselves, it could be central sterile or it could be the biomed, is where the rest of our products would be a benefit. And this kit is what we sell and is taken into the central sterile area, so they have their own self-contained tools that they can leave in central sterile, and also that a technician can easily use there on site. Okay?
Got it. The L700 is light source. Yeah, that is light source. both with the EndoScan and the EndoLume and EndoLume kit with the light source.
So they give you the light source also, lah.
Yeah. So you don't have to use the light source
From the hospital.
from the hospital.
Mm.
Exactly.
Yeah, I'm good.
Oh, go ahead.
I'm good. Can start selling, right?
Yeah, exactly. And when we do our next session on the EndoBench, you'll see that is the product that is a more higher elevated type product, and you'll see the vast differences. But this package here gives the user a basic package they can use for basic, like what we try to call triage in the hospital, on scopes and cables in their area.
Okay.
Go ahead.
Got it. This much more this is towards the user.
Correct.
Yeah.
And you'll see as Tim moves forward, if they use the EndoScan first, so now they get a visual inspection of the scope, they can check and see if it has any cracks, any dust, any moisture. Now they're going to move, with the EndoLume, they're going to move to the illumination side and determine the efficiency, the illumination efficiency of the scope or the cable.
Okay.
So what we'll see here, I'm actually going to switch over quickly, and again we'll look at the EndoScan here. It consists of the meter, the integrating sphere, and all the different components, different fittings. And in the background here we have our laminated reference guide. So this is large so that it's easy to follow along with, but fits inside of the EndoLume case.
Okay.
So when I flip back now to the presentation, we'll see one page of that reference guide describes each of the components that fits in the kit. So it talks about the integrating sphere and the sphere adapter, clamp for measuring endoscopes, several different types of Storz, Karl Storz adapters, a series of Wolf and ACMI adapters, and then a special Olympus adapter, as well as the optical bridge. So the user doesn't need to remember what these different types of fittings are, their names. They simply refer back to the guide here.
Okay.
The next pages of the guide has 3 different laminated sheets. It starts off with that cover page and then that page that shows the components. And then it goes in and has a page for each of the major categories of testing that you can do with the EndoLume. So here we see it shows you how to test a light source. You start with the light source, use the appropriate fitting depending on the brand or the turret setting, attach that to the optical bridge, attach the sphere adapter to that, hook it into the integrating sphere, read the output of the EndoLume. So we're going to switch over and show that. Here we go.
While he's hooking that up, point to the optical bridge real quick, or in the box right there.
Well, I'm just going to show everything here. So
Okay. The optical bridge is the patented area for the EndoLume. It separates the EndoLume from any other product, lux meter, etc., on the planet. Okay.
Okay.
So hopefully you can see the meter here. It shows 0 with no input to the integrating sphere. So as we showed in the guide, we take the light bridge, and I'm going to test, this is using an Olympus light source fitting. So I choose the Olympus fitting here, and I choose the integrating sphere adapter fitting onto here, and I can hook that into the integrating sphere, and then,
Okay.
oh, I'm sorry, I chose the Storz light source. Let me adjust this to the right fitting here. So, and I just clip it in. And now I see the output of this light source is about 840 lumens.
All right.
So depending on the light source, this is an LED-based light source. That's actually a very good output for this small light source. But that's my basic measurement now. It's 840 lumens. If this were a 300-watt xenon light source, I would say the bulb is about to go bad because this would be a low output for a 300-watt xenon. Again, if we remember that graphic that I showed before, it really should be 1,000 or 1,100 lumens minimum for a xenon light source. But this is actually a very good output for an LED light source.
Okay.
And again, the main thing to note here is that now we have, this is an objective numerical number of the lumen output of this light source. So if I were to change the fitting on this to a different brand and then retest it, I would get the same value with the EndoLume.
Okay.
So that's our baseline. If we flip back to the presentation here momentarily and go to the next slide, we'll see that it shows you how to test a light guide. So again, the setup's very similar. We use the light source. We plug the light guide into the light source, use the correct fitting, always using the optical bridge because it's part of the calibration procedure for the EndoLume, sphere adapter, and into the sphere. So I will switch back to the live view here, and we'll take the fitting out, and now we'll hook the fiber optic cable into the light source. So now we see the light coming out of the cable. We'll change the fitting on the light optical bridge to be the correct fitting for this Storz cable, and just thread that on.
Okay.
And then we'll thread the end of the cable onto the fitting. So now we see that we're getting about 380 lumens out of the light cable. I'm going to do the calculation on that. We get 380 divided by 840. 45%. So that's actually a very good output from this light cable. If we remember back to the graphic that I showed before, this is a 5mm light cable. We would expect a minimum of about 35% transmission efficiency through this type of light cable, and we're getting 45%. So this is a very good quality light cable. It's in good condition. It must not have very many broken fibers or any damage to the ends.
Okay. This is how it appears.
So that's a very straightforward measurement to make. Do you have any questions so far on the measurements?
No, we are fine.
Okay. So
Great,
then if we flip back, we'll see that the final measurement that we're going to make is testing an endoscope output. Here there's a little bit more detail because what we're going to do, and again the graphic walks you through how to set this up. The light cable into the light source, use the correct fitting. Now we use the correct fitting to attach to the endoscope, and then we place the tip of the endoscope inside the clamp system that comes with the EndoLume. And here in the upper portion of the laminated reference card, it shows you how to insert the tip of the scope into the clamp. Because we use the integrating sphere, it's really not that sensitive to this alignment, but the key here to note is that the tip of the endoscope should project just a millimeter or two into the integrating sphere. If it goes a little bit deeper, it won't make very much of a difference, but if it's recessed a little bit, then you'll lose light into the clamp. So you should follow this guide here. So we'll switch back over to the live view. So now I will take my optical bridge out of the integrating sphere, and I'll take the integrating sphere adapter off, and I'll now use the correct fitting to go directly to the endoscope. I'll take my Richard Wolf arthroscope here, and I'll clip the cable onto it. So now I have the light source through the cable going to the scope.
Okay.
Take the clamp out of the EndoLume kit, and I'll put the scope through so that it's a little hard to see here with the light shining out of it and on the camera view. But we see that the tip of the scope just projects out of the clamp mechanism.
Okay.
And we'll hook that clamp mechanism into the integrating sphere. And then we'll get a measurement through the endoscope. And we'll see that we get about 43 lumens.
43, okay.
Yep, 42.5, 43 lumens. It moves around just a little bit, but that's normal. So 43 divided by our earlier output of the cable we measured as 380 lumens. We're getting about 11.3% transmission through the scope. So if we recall from our sheet before, we said that for a 4mm arthroscope, it should be around 10 to 12.5% minimum. So we're right on the edge. This scope maybe has a little bit of loss in the collector on the side, or maybe in some of the fibers, or maybe there's some scuffing on the tip. So it's a little bit low for this type of scope, but it's on the edge of acceptable. I would probably pass it at this point.
So the possible cause of problem is on the scope, is that?
Yes, yep, absolutely. We checked. That is a great question, because that's exactly the point of using the EndoLume. We've now confirmed that the output of the light source is good. We've confirmed that the transmission efficiency of the cable is very good. Therefore,
Yes.
if we were to have a dim image problem, it is definitely isolated with the scope. And we see in our test data that this scope is right on the edge of acceptable.
Okay. Okay. Good. Interesting.
So, I mean, that again was a perfect question, is that there's no ambiguity, there's no uncertainty on what the problem is. You know, with the EndoLume, you've verified each of the different components' function, and you are certain which one is the trouble. Or in some cases, maybe there are several components that are on the edge. So as with anything, it's sort of a chain that links together. So if you had a complaint from the surgical theater of poor quality or dim image, you test the light bulb, maybe it was on the low side, maybe the cable had some breakage in fibers a little bit, and maybe the scope was a little bit weak. So all of those things together make a bad image. You'd have to kind of go through the whole system at that point. Much more common, though, would be maybe the bulb needs to be replaced, maybe the cable has some broken fibers, or maybe the scope has some sort of an issue and should be sent out for repair. With the EndoLume, you've identified uniquely which one of those components is the problem area.
Excellent.
So what I'm going to show real quick, as long as you're okay with this, Bill, is the paper that I'm working on right now.
Yes.
Most of even other brands, they will use Endoscope, Olympus, or this.
So as I mentioned earlier, I'm still finishing up some editing on a paper that I'm writing to show the difference between trying to make these measurements with the lux meter versus with the EndoLume.
Lot of difference. Yeah.
So with a lux meter, the difference in trying to measure the output of these different turret settings, let me put this image and see if I can do this here a little bit. Make this image a little smaller, perhaps. So we can see that the light source here, I don't have one with a turret on it, but I have one where you simply change the nose piece settings. So right now, we kind of see how bright this light is when it's set up for a Storz light source. If I were to remove this adapter, it is now set up for an ACMI light source. It's a little hard to see on the camera, but we'll see there's a lot more light. It's a lot brighter image out of it. This is exactly what this paper talks about. where if we look at the output of a light source or a cable measured with a lux meter, we can get very, very different ratings. So this section is measuring a light cable. So the output of the cable is constant. It doesn't matter which setting you use on the light source, but the measurement with the lux meter of the light source can vary so that it actually can show that the output of the cable is brighter than the input when you try to use a lux meter. And that's because of that big variation in how you measure the input. So if I go back to a page before in this paper, and we see that measuring just the same light source in the different turret settings, you could measure anywhere from 51,000 lux to 224,000 lux for the same light source in the same settings just by changing the turret setting. So that's 120% difference. It's well, almost, actually that's from the average. It's actually a factor of 4 from the weakest to the strongest. If we do that same measurement with the EndoLume and all the different turret settings, we get a small variation of just a few percent. And experimentally, I've actually shown that this is variation in the turret. With other light sources that have a little better quality turret design, you actually get virtually no difference in the output, which is as it should be. So then, by using that variable input from the lux meter, depending on which turret setting you use, you can actually show that the cable is brighter on the output than the input, or dimmer. And again, it depends which setting you use. With the EndoLume, however, it doesn't matter which setting you use, they all measure approximately the same, 30% transmission efficiency for the cable that I tested in this paper. So that's the difference between trying to use a lux meter and an EndoLume. Lux meter, you have to be very careful. The alignment's very sensitive and critical. And if you change the type of fitting that you use, the turret setting, you completely change the results that you're looking for, that you get. With the EndoLume, a cable is a cable. It doesn't matter which manufacturer, which settings you use, they should all be about the same performance.
Okay.
And that was the end of the presentation.
Great. Very interesting.
Did you understand the explanation between the EndoLume and the lux meter, the difference? Do you understand?
Yes.
Yeah.
Okay. Okay. It's a big difference in terms of the lux meter and the EndoLume. Any questions on either the product or the sales side, or any questions? I know this is a lot of information, but and Tim will send you, I know he's recording, as well as he will send you the PowerPoint also separately.
Yeah, that would be good, yeah. So,
The light source, we have to change the light source. How many hours? What is the light source?
okay, there's a question here from Balvinder that the light source, right?
Mm-hmm.
We have to change the bulb, right? The light bulb after certain hours or things like that.
Yes. What is the question, though?
No, for the light source, the light source for the EndoLume kit, right?
Oh. No, there's two key things to remember there. First, the light source that we provide is an LED light source. So it has an expected lifetime of on the order of 50,000 hours. However, even if it did have some variation to it, the way that you use the EndoLume is you always test the light source input and then measure the light output of the device that you're testing. So it doesn't really matter whether the light bulb or the light source is brand new or has a very high output, you always scale to it. So
Okay, because you take the reference points here from the input.
exactly.
Okay, all right, okay.
So you don't really have to worry about how, what the quality or output of the light source is you're going to measure for it. And then again, light source that we do provide is an LED, so it should last 50,000 hours.
Okay, great.
Hey, Tim, can you go through the Excel spreadsheet for the EndoLume that we provide?
Yeah,
user?
absolutely. That was the other thing we wanted to do.
Right. So as Tim was mentioning, because the OEMs do not share their information, we over the years have collected our own data to be able to help the user understand what the readings mean in terms of good or bad or fair. And so what we do is we provide an Excel spreadsheet. We call it an EndoLume workbook, and this is what Tim's going to show you now.
So what we have up here on the screen, this is the actual Excel spreadsheet. This is the same graphic that I showed earlier in the presentation, except now it's a live data where you could actually change these settings. And it does depend somewhat, a 300 watt xenon from different manufacturers can have different kind of quality bulbs and outputs. So you may, as an end user, want to modify these or to make new categories of, say, a 300 watt xenon from Stryker versus one from Richard Wolf. You may have slightly different limits that you want, but these are good starting point limits. So if we then look at here in the working tab for the light sources here, we see that you can type in your model number and your serial number. The manufacturer and the light source then are drop downs from those other tabs. So we see this top one is listed as a 300 watt xenon.
Yes.
So its output is measured at 1168 lumens, and we said 1100 was the minimum, so it shows as green. If, however, the user were to measure, say, 945 lumens and enter that data, it would automatically show that it's red and it does not meet specification. So this lets the end user set these limits on one tab. So you could come over here, and let's say if instead I've decided that for my Stryker maybe light source, I'm okay with 900 lumens being my minimum. I could go back then and show, well, now it shows green again because that's what I changed it to.
Oh, a limit, okay.
Or you can just use our default limits of 1100 lumens, and then when you go back, you see that 945 lumens that you measure shows that it does not meet specification. So this is just a customizable spreadsheet that allows you to track that data and that we provide the basic starting points for what good and bad mean. Same with light cables. So a 5mm light cable, the user can use the drop down based on whether they enter other data. So 3, 4, and 5mm light cables are typical. Let's say, for instance, though, that the user has an odd brand that comes with a 6mm cable. They could enter that data in, and as a larger cable, it should have better output. And then we go back to the light cable tab, and they could have new data with their 6mm cable. You don't have to do the calculation that we showed in the other one. You could just enter in, say, 1000 lumens were the input to the cable, and the output were only 400 lumens, which is only 40%, which does not meet that 45% specification that I mentioned.
Okay.
So this has, again, starting information for the users to work from, but it is customizable so that they can add new cables and change limits if they would like to as they go.
Okay.
And it also has a tab for endoscopes. So same calculations, measure the input, measure the output. The spreadsheet will calculate whether that meets your specifications from the other tab. So it's a very handy and convenient tool for tracking them. Again, you can have the model number and the serial number. It is just an Excel spreadsheet, so they could add filtering to it, and you can go back and filter for the serial number or the model, and look at the performance through the past.
So, Samarjit, what would happen is the hospital, the best thing for the hospital to do is to test or baseline all their scopes, light cables, and light sources. The best would be if they baselined them when they were new, and they would, on the first tab, under the equipment tab, they would then put in all that data, and they could set their guideline. They could run a test, and they could set their guidelines there. And then they know over time, for that particular cable or scope or light source, based on a serial number, they could watch the degrading or of the device over time. So they could see that eventually it goes down and it hits the red area, and they know, okay, it's time to change it or get it repaired, etc.
Yeah. Over here they said actually about 500 hours for the light source to be changed, the bulb.
It depends on the company. It's 500 hours, maybe 800 hours. And again, I'm not sure how they do it in your country. Here in the U.S., we run into very different attitudes depending on the hospital you're talking to. Some of them change it on the hour meter like the manufacturer recommends. Other hospitals, they continue using it until it fails, until they get a complaint or it just stops working, and then they replace the bulb. And then other ones may do things like monitor with an Endo Illume to see how the bulb's doing, actually do PM, preventative maintenance checks, and replace the bulb when it starts to show weakness.
Okay.
So it depends on the user that you're talking to, how they do that. It is a tougher sell for the light bulb part of it if they simply use the hour meter and they replace it, when that happens. However, even with that, as I'm sure you're, seeing in your own home, putting light bulbs in, they come with a rating on the package for how long they should last, but it doesn't mean they're always going to last that long. So,
Yeah.
even with that, if you get a complaint of a dim light source and the hours are only, say, 450 hours when it's supposed to be replaced at 500 hours, it could still be that the bulb is the problem. So that would actually be misleading to just use the hour meter at that point. And the Endo Illume would let you make certain whether the bulb or the cable or the scope is the problem.
Yep. Okay, great. Will you be sharing this this sheet with us?
Certainly, yes.
Yeah, absolutely. We give it to all the distributors, as well as then you would give it to your customer every time you sold an Endo Illume kit or just the Endo Illume itself. You could then give this to them each time.
Yeah, a template for them. Yeah. It's easy for them to do the maintenance.
Any other questions?
Any other questions? So far, that is done. Yeah. We will have many questions when we are out. Okay.
Yeah, and that's understandable, and we can easily repeat this training again, or based on your questions, we can do this again at any time you'd like. I mean, so our goal is to bring you and your sales team up to speed as quick as possible. So we ask that you ask questions, and if you want us to kind of repeat this, or at least come back online to just talk and answer questions with your team, we're more than happy to do so.
Okay, great. Thanks a lot for the support.
Sure. And then what we'll do is maybe look at your calendar over the next few weeks, because the next session we will do will be for the Endo Bench.
Yeah, probably a week after next.
Okay.
Yeah.
Yeah, let us know.
Anyway, I'll
Let us
get
know
back to you.
what day and time,
Yeah.
and we're happy to we'll schedule another one.
Okay, great.
Excellent. Well, we are very pleased to have your company with us in our distribution network, especially in that part of the world. Looking forward to, as you can see, we have not sold, really done any marketing over there ever. So you sit in a kind of a new open territory, if you will.
Yeah, yeah. A lot of education needs to be done now.
Yeah,
Out there.
yeah, and you'll find that other than the Lux meter, in terms of competition, we have very little competition. So many of the hospitals, they struggle, especially with their scopes, because they don't know what they can do. They don't know there's any equipment out there, and that's who we are, at least providing them tools that they could control their own destiny, and they can actually save some money, because we've had many customers, by using our equipment, they're able to keep good scopes from going out back to, in your case, the OEM for repair.
Yeah.
They can now determine if they've got a good cable, good scope, bad scope, and so it actually saves them money at the end of the day.
True. Now they are just sending blindly to
Exactly.
manufacturers.
Yes,
Yes,
And they
blindly
cost a
is
lot.
actually yep, absolutely.
We've even learned recently from our customers that even from the OEMs, the quality is not always great. Again, up until now, people like, the OEMs, Carl Storz or something, say, take our scopes and just know that they are good. But we've had end users using the EndoBench test brand new scopes coming in and find problems with them.
Oh, okay.
Yeah, they're able to. One hospital rejected and sent the bad ones back, and had to get them brand new. Had to get them replaced.
Mm-hmm.
So just like a new car comes with a warranty, you need to be able to check the scope, even a brand new scope, make sure it performs as you'd expect.
Correct. During testing and commissioning. Yeah.
Yep.
Great, man. Great.
Okay, sir. It's been our pleasure.
Move forward.
And again,
Yeah.
Tim will send you the additional information, the Excel spreadsheet, the PowerPoint, and please feel free to come to us for additional questions or information.
Yeah, and customer list. If you have one in the Excel sheet or what customers that you have sold the unit and all that as a reference, that would be good. Yeah.
Yeah, I don't think that we maintain a very good customer list for the EndoLume, EndoScan products.
Okay.
We can certainly put something together, at least a sampling.
Yeah, almost every major hospital, or a lot of them, I should say, have the EndoLume, EndoScan in their either biomed or central sterile area.
Mm-hmm.
Yeah, a tool that they must have,
Yes, yes, absolutely.
Yeah, true.
Okay, salamat malam.
Okay, selamat malam. Okay, thank you very much, guys, for the time.
Our pleasure.
Have a good night.
Yeah, I'll talk to you soon.
Thank you.
Good night.
Okay, thank you. Good night.
Yes.